Okay, hello all. So today's module, we have an interesting topic that is we will review an atomic structure of two popular semiconductor materials that are used in microelectronics industry. So one of them is called as germanium right here, and another one is a silicon. So what we want to understand here, we want to understand the Bohr's atomic model of this material, germanium and the silicon. So you see that there are these rings, that is ring number one, ring number two, ring number three, ring number four. So there are four rings right here in case of germanium. These rings are called as orbits, or they are called as shells. And at the core, inside these rings, we have this particular element that is called as nucleus. And in this nucleus, you have protons, number of protons, and number of neutrons. Similarly, for the silicon also, you have orbits or shells, in this case, one orbit, second orbit, and the third orbit. And at the very core of this silicon atom, you have a nucleus, and inside the nucleus, you have number of protons and number of neutrons. So neutrons do not carry any charge in each case. However, protons carry charge in each case, and that charge is positive in nature. That's why we have plus sign both for the both elements. Now, we understood what is an orbit, what is a nucleus, and the outermost shell of each of these silicon or germanium atom. That outermost shell or an orbit consists of electrons again, and those electrons are called as valence electrons or free electrons, are ready to be free electrons. We will see in a moment why they are called as valence electrons or free electrons or ready to be free electrons. Okay, so this is Bohr's atomic model for germanium, and this is Bohr's atomic model for the silicon. Now, as I said, the outermost shell in both of these, we haven't shown any electrons available. However, there are electrons, as I said, and they are called as valence electrons. So let us see what those electrons are. So you see that there are four electrons in the outermost shell for the germanium atom. And there are four electrons, 1, 2, 3, 4, in the outermost shell or orbit for the silicon. And these electrons are called as valence electrons or ready to be free electrons because they require relatively lower potential, ionization potential, or in simple word, we will say they require relatively lower energy to free them from the outermost orbit so that they can contribute to the conductivity inside these materials. And the electrons which are inside the orbits, the closer to the nucleus, they will require higher and higher amount of energy to liberate themselves. Okay, so that's the basic here. So in the form of table, we can see there is a table here. Left side is germanium, right side you have a silicon. So there are total 32 electrons in the orbit of a germanium. So if you count these, you have total 32. In each of the orbits, there are specific number of electrons available. However, we just note and we only want to remember that in the outermost orbit of germanium, there are four electrons in the outermost or valence shell. for germanium as well as 4 electrons here for the silicon. In case of silicon, the total 14 electrons in the orbit. If you count these electrons in each of the orbits, there are total 14. But in the outermost shell, there are only 4 electrons. And that's what we want to remember. So the atomic number of germanium is said to be 32 because it carries 32 electrons in total in its all orbits. And atomic number of silicon is said to be 14 because it carries total 14 electrons in all of its orbit. Okay, so these are intrinsic forms of semiconductors, and we would now see how this is a single atomic structure for silicon. This is single atomic structure for the germanium, and we'll see in the next module how these single atoms consisting 4 valence electrons form a bonding with its neighboring atom in the same crystal lattice of either germanium or silicon. We will see the concept of covalent bonding. Specifically, we'll see covalent bonding and we'll see how these electrons find ionization energy or ionization potential to liberate themselves so that they can contribute to the conductivity inside the material. So now the question for you is that write in the comment what is the atomic model, Bohr's atomic model for some other popular material, for example, phosphorus, aluminum, etc. So hope you found this module useful. And if you did so, share it with others for wider reach and stay tuned for more engaging and informative content like this. Till then, we wish you happy learning.